embedded project. My name is Manar Hatem, 40-MET. My ID is 40-5632. The embedded project was mainly divided into different parts. The car motion in a lane and without hitting an obstacle. Display, where it displays the fuel level of the car, and the raindrop sensor, which detects if there is rain or not. The other features like the real-time clock to display the clock of the real-time clock on the display, and MP3 player to play the MP3, and joystick servo to represent or simulate the motion of the mirror. Now I'm going to explain a detailed explanation for the display and how it works. The display has 4 rows. The first row displays the fuel level, the second row displays the rain detection, and the third row displays the time. The fuel detection value changes when the water level sensor enters the water. So as the water level sensor emerges into the water, the fuel level changes. Okay. The rain detection value changes when the raindrop sensor emerges into the water. Meanwhile, the buzzer is triggered because there is rain. Once I remove the raindrop sensor from the water, the rain detection value turns back to 0, indicating no rain, and the buzzer stops working. While the fuel level and the rain detection is running, the time clock is running using the RTC, which will be explained.
Hi, my name is Mohammed Mahaya. My ID is 40-13220. I'll show you 2 parts in our project. The first part is this hardware component, which is used for to display which is related to the RTC, which is used to display time on this screen. This hardware component allows us to use functions such as time, now.hour, now.seconds, now.minutes. Also, the second part that I'll show you in the project is the servo. The power mirrors, which is controlled by the servo motors. We control it using this joystick. The maximum and minimum values of the y-axis in the joystick were mapped to the maximum and minimum values of the mirrors.
Hello, I'm Mohammed Hussein, 40-16509. I'm gonna explain the motion of the wheel and the MP3 player. As you can see here, we have 4 different wheels with 4 different motors. Each motor is connected to the edge bridge. Each 2 motors on the right side and the left side are connected to a single connection on the edge bridge. This is for the right wheels, and it's for the left ones. We're also having 2 enabled signals, which is used to control the speed of the motor. The edge bridge is also connected here to the positive and the ground. We're using a battery of 6 volts connected in series to another 4 batteries, each 1.5 volt. The speed of the motor is controlled using these two enabled signals, using a PWM signal ranging from 0 to 255. The motion of the car is controlled using these 2 sensors. This is an ultrasonic sensor, and this is a lane detection sensor, and these 2 will be explained later. Moving on to the speaker and MP3 module. This is the MP3 module. It has a micro SD. Which we uploaded some songs on it. It's connected to the Arduino and the speaker. In the implementation of the MP3, we used semaphores to control the 3 buttons for the play, pause, the previous and the next song. We can If we hit the previous or the next button, it will not work unless it's already playing. So we can play.
Hello guys, my name is Ahmed Hassan. I'm in the faculty of MAT, Computer Science, 40-7470. I'm here to explain the safety procedures that we took for the motion of the car. First of all, as my colleague explained, this is the ultrasonic sensor, which is mainly used for the braking module, a braking system. So mainly it has, let's say, 4 inputs, 4 pins, 2 of which are the VCC and the ground, and the other 2 are called trigger and echo. Both of them are PWM pins. Mainly the trigger is the input, so I'm inputting, let's say, a signal, and it travels back and forth, and the echo calculates the duration that this signal took to go and come back. And then mathematically, we calculate the distance in which the signal actually went and got back. And with this distance, we control when will the car stop, or let's say the maximum distance that the car should see for the stop procedure to be done. And this is a lane detection sensor, usually known as a black-white sensor. Mainly it detects if the lane that the car is walking on is black or white. So here it's not detecting white. As you can see, it's buzzing, but if we put it on the white lane, it stops buzzing because it detects a white signal. Moving on to another safety module, and it is the seat belt. So right here we simulated a seat belt using a button that if we clicked, that means that the user, the car now is working. So without the seat belt, the car won't work, which is even more safety. One more thing to say, the black-white sensor actually prints out of lane when it detects a black signal. As we can see, it's sitting on a black tape.